Let's see the answer of Pearson Edexcel for chemistry. And this test was conducted on May 2025. This is a paper of 1 CR. Okay, so let's start with the question 1. This question is about the three states of matter: solid, liquid, and gas. Question A. Solid, liquid, and gases can be changed from one state to another. The box gives the name of some changes of states. So we have condensing, evaporation, freezing, melting, and sublimation. Use words from the box to answer the question. Give the name of change from liquid to solid. So it is freezing. Next, give the name of change from liquid to gas. So it is evaporation. Next, give the name of change from solid to gas. So it is sublimation. Question B. Describe the arrangement, movement, and energy of the particle in gases. So first one, the particles are further apart and they can move randomly and the energy is less since the attraction force between the particle is less. Question 2. This question is about the rusting of iron. Oxygen is needed for iron to rust. Name one other substance needed for iron to rust. So it will be water. Next one, give the chemical name for rust. So it is iron trioxide. Question B. The diagram shows method A and method B, which are both used to prevent iron from rusting. Question I. Describe how method A prevents iron from rusting. First thing is paint acts as a barrier. So it prevents iron from oxygen and water. Question II. Name method B. So it is galvanizing. Question III. Explain how method B prevents iron from rusting even when the zinc layer is damaged. Okay. First one is zinc is more reactive than iron. So zinc loses electrons. in preference to iron. Question 3. Copper sulfate and sodium hydroxide react to form insoluble solid copper hydroxide. Crystal of copper sulfate and sodium hydroxide are placed at opposite ends of a container of water. Solid copper hydroxide forms after several minutes. The diagram shows the container at the start and after several minutes. Question A. Name the two processes that must occur before the copper to hydroxide form. So that two processes consist of dissolving and diffusion. Then question B. The experiment is repeated with the water at higher temperature. So explain in terms of particle why the copper to hydroxide take less time to form. The first point is that at higher temperature, the particle move faster. Particles move faster. So once the particles move faster, they collide. They collide and react after a shorter period of time. After a shorter period of time. Then question C. The formula of copper to hydroxide is this one. Give the number of different elements in copper to hydroxide. So we have three different elements, which are copper, oxygen, and hydrogen. So the answer is 3. Then give the charge on the copper ions in copper hydroxide. Since the charge of hydroxide is -1, -1 times 2 is -2, but the overall charge of this compound is 0, so that means the charge on copper ion is +2. So the answer is 2 positive. Question 4. This question is about atoms and ions. A. Table 1 shows some information about the subatomic particles. Complete table 1 by giving the missing information. So relative mass of neutron is 1. Relative mass of electron is 1 over 1840. Now relative charge of proton is +1. Then B. Table 2 shows the number of protons, neutrons, and electrons in species A, B, C, D, E, and F. Use the information in Table 2 to answer these questions. Each species may be used once, more than once, or not at all. Give the letter of the species that has 3 electrons in its outer shell. So 3 electrons in its outer shell, right? So we have to write the electronic configuration first. Okay, so starting with A, it has 13 electrons, so electronic configuration is 2s3. B is 1, C is 2s, D is 2s as well, E 2s, and also for F 2s. So therefore species A has 3 outer shell electrons. So the answer is A. II. Give the letter of the species that is an ion with a 3 negative charge, which means it has electron more than proton 3. So in this case, we can see that it will be species D, because it has 7 proton, but it has 10 electrons. So electron is more than proton by 3. So it is species D. Question III. Give the letter of the species with a mass number of 19. Mass number equal to the number of proton plus neutron. So in this case, proton plus neutron is 19. It will be species C, because if we combine the number of proton and neutron together, it is equal to 19. So it is C. Question C. A sample of lithium contains 2 isotopes, lithium-6 and lithium-7. In terms of subatomic particles, give one similarity and one difference between these isotopes. Similarity is they have the same number of protons. They have the same number of protons. And for the difference is that they have the different number of neutron. Okay. Then question D. A sample of magnesium contains 79% of magnesium 24, 10% of magnesium 25, and 11% of magnesium 26. Calculate the relative atomic mass or AR of this sample of magnesium. Give your answer to one decimal place. So relative atomic mass or AR equal to 79 times 24 plus 10 times 25 plus 11 times 26 divided by 100. So we will have 79 times 24 is 1896 plus 250 plus 11 times 26 is 286 divided by 100. So it is equal to 2432 over 100. So it is equal to 24.3. So the answer is 24.3. Question 5. This question is about element in group 7 of the periodic table. Complete the table by giving the missing information. So the physical state of chlorine will be gas. The color of the bromine is brown. And the physical state of astatine is solid. Next, the order of reactivity of group 7 elements can be shown by using displacement reaction. When chlorine is added to sodium bromide solution, chlorine displaces bromine. Give chemical equation for this reaction. So we have Cl2 plus sodium bromide NaBr. And since chlorine displaces bromine, we will have sodium chloride plus Br2. And then we have to balance the equation. We have 2 chlorine on the left, but we have 1 on the right. So I have to put 2 here. Then it will affect the number of sodium. Sodium will become 2 here, but we have only 1. So on the left, so I'll put 2 here. And the last one, number of bromine is 2 on both sides. So the balancing equation is done. Then next one, explain whether a reaction takes place when bromine water is added to sodium chloride solution. The answer is no, because bromine is less reactive than chlorine. Okay. Next, the displacement reaction between potassium acetate and bromine can be represented by this ionic equation. Explain why this is described as a redox reaction. Okay, first one is acetate loses electron, whereas bromine gains electrons. Question 6. A student uses the reaction between magnesium and dilute hydrochloric acid to prepare crystals of hydrated magnesium chloride. The student adds excess magnesium powder to hydrochloric acid. This is the equation for the reaction. Question A. How does hydrochloric acid behave when acting as an acid? Okay, so let us see the oxidation number. The oxidation number of chloride is -1, whereas the oxidation number of hydrogen will be +1 in case of hydrochloric acid. And if we look at the right hand side, the oxidation number of hydrogen gas is 0. So the oxidation number decrease, right? So that means it is an electron acceptor. Okay, then question B. State one observation made during this reaction. So since there is an hydrogen gas here, so it is freezing. Question C. Give a reason why the student adds an excess of magnesium to the dilute hydrochloric acid. In order to make the reaction to be completed. Okay, then question D. Describe what the student should do to the mixture formed in C to produce pure dry crystal of hydrated magnesium chloride. Okay, first one is filter the excess of magnesium. Then heat, then allow to cool and crystallize. Next, pour off excess liquid. And the last one is leave in a warm place to dry. Question 7. A student reacts small chips of calcium carbonate with an excess of dilute hydrochloric acid. This is the student's method. Add 5 grams of small calcium carbonate chips to a conical flask. Add 30 cm cube of dilute hydrochloric acid, which is in excess. Quickly add a cotton wool plug and place the conical flask on a balance. This is the equation for the reaction. The reading on the balance decreases as carbon dioxide gas is lost through the cotton wool plug. Question A. Calculate the mass reading on the balance when all of the calcium carbonate has reacted. Assume that all of the carbon dioxide gas is lost through the cotton wool plug. Okay. So we have to find the mass. Okay, so first of all, I will find the mole of calcium carbonate first. So mole of calcium carbonate equal to mass divided by mR. Okay, so mass of calcium carbonate is 5 gram. Okay, so I will put 5 here divided by mR, which is 100. So it is equal to 0.05 mole. Okay, then if we go back to the equation, the coefficient of calcium carbonate and carbon dioxide are equal, which is 1. That means that the mole of calcium carbonate must be equal to the mole of carbon dioxide, and it is equal to 0.05 mole. Okay, so therefore mole of carbon dioxide gas equal to mass divided by mR of carbon dioxide. So if we want to find the mass, it will be equal to the mole of carbon dioxide times mR. So mole is 0.05 times mR, which is 44. So therefore, mass of carbon dioxide is equal to 2.2 gram. Then the reading on the balance will be equal to 122.2 minus 2.2. So it is equal to 120 grams. So the answer is 120. Experiment with a different mass of calcium carbonate and a different volume of dilute hydrochloric acid. The hydrochloric acid is in excess. The student records the total mass of carbon dioxide produced at 1 minute intervals for 8 minutes. The table shows the student's results. Okay, so I plot the student result. The first 3 have been plotted for you. Okay, so we will have 1.64, so it will be this one. Okay, 1.64, and then 1.72 at 4, 1.68, 1.72, and then 1.76. Okay, and then 1.8 from 6, 7, and 8. So 1.8. That's it. Then next, okay. Question II. Draw a curve of best fit through the points. Okay, so it will be like this. Let me draw again. Okay, then calculate the rate of reaction at 2 minutes by drawing a tangent to the curve and calculating the gradient of the tangent at 2 minutes, right? So, okay. Okay, so I will have this point, which is, and this point. Okay, so the gradient of, the coordinate of this point will be 2.2 and 1.44. And this point will be 1.8 and 1.242832. 1.32. Okay, so it is equal to, gradient will be 1.44 minus 1.32 divided by 2.2 minus 1.8. So we will have, let me use 1.44 minus 1.32, which is 0.12 divided by 2.2 minus 1.8, which is 0.4. So 0.12 divided by 0.4 is 0.3. That's it. And okay, explain why the shape of the graph changes during the 8 minutes. Okay, because why the shape of the graph changes, right? Okay, 4 marks. First one is the curve is steepest at the start because the reaction is fastest. Then the curve become less steep because the reaction slows down. Okay. Then question C. The student repeat the experiment using the same mass of calcium carbonate but as powder rather than chips, keeping all other conditions the same. Explain the effect of this change on the rate of reaction. So the rate of reaction increases because the surface area increase. And then there are more collision per unit time. Question 11, which is the last question of this paper. This question is about sodium sulfate. A teacher finds an unlabeled bottle containing a white solid. Describe test to show that the white solid is sodium sulfate. Okay, first one, in order to test the sodium ion, the student must do a flame test. And the color of flame is yellow. Then, in order to test the sulfate ion, the student must add hydrochloric acid. Add hydrochloric acid. And then add barium chloride solution. And then the result is the white precipitate will be formed. Okay, then question B. A student has a sample of crystals of hydrated sodium sulfate. The student uses his apparatus to find the value of X in sodium sulfate with X water. So this is the student's method. Find the mass of the empty crucible, then add some hydrated sodium sulfate crystal to the crucible. Find the total mass of the crucible and hydrated sodium sulfate crystal. Heat the crucible to remove water from the crystal. Find the mass of the crucible and its contents every 2 minutes for 10 minutes. So the table shows the student result. So question I. State how the result shows that all the water has been removed from the crystal. So you can see that the mass after 8 minutes and 10 minutes are constant. Okay, so the last two results are constant, or you can say are the same. Then calculate the mass of anhydrous sodium sulfate remaining after heating. So remaining after heating, right? Mass of sodium sulfate remaining. Okay, so mass of sodium sulfate equal to 26.79 minus 23.57. Okay, so we will have 26.79 minus 23.57, which is equal to 3.22. I have to change this one a little bit, in fact, because it has some water here. It's not a pure sodium sulfate. Then, if you want to find the mass of sodium sulfate after heating, right? So we will have 24.99. It here. Mass after heating is 24.99 minus 23.57, which is equal to 24.99 minus 23.57, which is 1.42. So the answer is 1.42. Then calculate the mass of water lost. So mass of water lost equal to 3.22 from the previous question minus 1.42. So it is equal to 1.8 gram. Then use the student's result to calculate X in the formula of sodium sulfate with X water. So we have the mass of sodium sulfate, which is equal to 1.42 divided by mR, which is 142. And we will compare with the mass of water loss, which is 1.8 divided by mR of water, which is 18. So it is equal to 1.42 divided by 142, which is 0.01, and 1.8 divided by 18, which is 0.1. And since 0.01 is less than 0.1, so I will divide on both sides with 0.01. So it will be 1 and 10. So therefore, the value of X equal to